they're involved heavily within the allergic response, so that very sudden dramatic response that your immune system launches in case of, say, for instance, a peanut allergy. So the airway narrows, the lips may swell up, there can be rashes and increase in pulse rate. That's to do with the IgE antibodies being released. IgG, you may be familiar with those in terms of food intolerances, so they're often produced by the immune system as a more kind of low-grade chronic response to a food intolerance, so it's not as serious as a food allergy. Then we have IgA. Secretory IgA is found within the digestive tract, and it's a very protective effect there. We also have IgD and IgM as well, and there's still lots of research going into the full roles of these immunoglobulins and what they do in the body. We then have the cell-mediated branch of adaptive immunity, and this is the work of the T cells. And again, we have more subtypes. So within the T cells, we've got regulator T cells, effector T cells, and memory T cells. And the regulator T cells are divided into T helper cells and T suppressor cells. There's lots of different teams of these T cells, and they're working together to promote or inhibit activities of both the cell-mediated and the antibody-mediated immunity. So they're working to either help the immune response or suppress it, to keep it in balance so that it is stimulated when it needs to be stimulated, but it's not overly stimulated, and then it can come back into balance. So like I say, we've got these two main branches, the innate and the adaptive, and they are still working together. There's a close interplay there, and there is within the two sides of the adaptive immunity as well. So T cells and B cells are still communicating with each other, and the way everything works together, that is the total overall immune response. Now, if we think of the functions of a healthy immune system, what do we want our immune system to do?